Section 9.4, Normal Approximation to the Binomial Distribution. Suppose a fair coin is flipped 15 times. Find the mean and standard deviation for the number of heads. So we have a formula here. Remember this little symbol here means our mean, and that's going to equal to how many times we're continuously doing the same thing times the probability of that event. And the standard deviation, so again this is the standard deviation symbol, is equal to the number of trials that we're completing times that probability times 1 minus the probability that it happens. And we're taking the square root of it. So the number of times we're actually flipping our coin is 15 times. And the probability that we obtain a heads is equal to 1/2, right? 1/2 the time we should expect to get heads. So we can find the mean by simply replacing into our formula. So the mean is equal to 15 times 1/2, which is 15 halves, which is 7.5 is our mean. Our standard deviation then is the square root of n, which is 15, p, which is 1/2, all multiplied by 1 minus 1/2. So this is equal to the square root of 15 times 0.5 times 0.5. 1 minus 1/2 is still 1/2. So if I multiply all those together, I should get 3.75, and now take the square root of that, gives me 1.94. So we're going to use that information on how to get mean and standard deviation when we have a binomial distribution here in the next page. So let's say that coin is flipped 15 times. Use the normal distribution to approximate the probability of getting exactly 9 heads in 15 tosses. So from section 8.4, we learned the formula, the combination of n choose x times that probability to the x power times 1 minus that probability to the n minus x. We're going to follow that same procedure here, knowing that we do have some information. So we want to have 15 times, we want to choose 9 of those to be heads. We'll multiply that by our probability, which we decided was 1/2, so 0.5 to the power of 9, times 1 minus 0.5 to the power of 15 minus 9. We have to find 15 choose 9, so remember combinations is 15 over 15 minus 9 factorial 9 factorial, which is the same as 15 factorial over 6 factorial 9 factorial. So I can rewrite 15 as 15, 14, 13, 12, 11, 10, and 9. I chose 9 because it was the closest one there, so we can cancel this out. So multiplying 15 times 14 times 13 times 12 times 11 times 10, dividing that by 6 times 5 times 4 times 3 times 2 times 1 will end up giving us 5,005. 0.5 to the 9th power is 0.0019533125. I certainly could have shortened it up, but we want to get as accurate as possible. 1 minus 0.5 is 0.5, and 15 minus 9 is 6. So 1/2 to the 6th power is 0.015625. And go ahead and verify that with your calculator. The next step is simply to multiply all of these together. So when I multiply all those together, I get 0.1524 for a probability that when I flip 15 times, the probability of giving 9 heads is about 15%, is what that means. So consider a sample of 100 drivers in Atlanta where 40% of the drivers exceed the speed limit by at least 20 miles per hour. Let's use the normal distribution to approximate the probability that at least 50 drivers exceed the speed limit. So we have to do at least, so we want more than. we first need to find the mean and standard deviation because we're going to need to find a z-score. So our n is equal to 100 drivers, so 100 subjects. The probability is 40%, so 0.40. So to find the mean, we'll take 100 times 0.40 from the previous page's formula. So when I multiply that, I get 40. To find the standard deviation, we take the square root of 100 times 0.4. Times 0.4 times 1 minus 0.4. That gives me the square root of 100 times 0.4 times 0.6, which gives me the square root of 24, which gives me 4.899. The previous section decided that we could find the z-score if we took the value that we're looking at minus the mean divided by standard deviation. So we want at least 50 drivers, so we need to choose something slightly smaller. So I'm going to choose 49.5, because if we did 50, it wouldn't quite count all of them, so just slightly less than 50 is 49.5. Subtract 40, which is the mean, and then divide by our standard deviation. So when I subtract and divide, I see that I get 1.94. And this is our z-score. So we need to find in the back during Appendix C, I need to look at 1.9 on the left, and I need to look at 0.04 on the top, and where those collide is 0.9738. So what we just found was the portion to the left, because remember, it's always to the left. But we want more than, so we want at least 50. So we're curious about this portion here. We know that the shaded portion plus the unshaded portion is equivalent to 0. Is equivalent to 1. So if I take 1 minus my 0.9738, that's equivalent to 0.0262. And that is the probability that at least 50 drivers exceed the speed limit. So about nearly 3% of 100 drivers will exceed the speed limit. Let's find the probability of finding between 42 and 48 speeders in the random sample of 100. So we already found the mean and we already found the standard deviation. So we need to find, we're looking for in between, so we're looking for this area here. So we need to find the z-scores for 42 and 48 speeders. So we want to do slightly less than 42 and slightly more than 48. So let's do the z-score. Slightly less than 42 is 41.5 minus the mean divided by the standard deviation. That's equal to 0.31. And slightly higher than 48, so let's do 48.5. Minus 40 divided by 4.899. It's 1.74 when we subtract and divide. So now we need to find those probabilities within the bulk of our Appendix C. So we want to go 0.3 on the left-hand side, and then we want to go 0.01 on the top. And we'll see that'll give us the area of 0.6217. And we'll do the same for 1.74. We'll go 1.7 on the left, and we'll do 0.04 on the top. And we'll see that corresponds to 0.9591. In section 9.3, we learned that if we were to subtract those two numbers, we would be able to get the in-between portion. So 0.9591 minus 0.6217 gives us 0.3374. So about 34% of the people between 42 and 48 of them will be speeders in a sample of 100. Now your homework for this section has a separate piece of paper to go with it. you can follow this exact same example for your homework problem number 3, except I just give you two different numbers instead of 42 and 48. They're two different numbers. You can also do the coin flippage as well for the first page. So I hope this helps you, and this concludes section 9.4, normal approximation to the binomial distribution.